My name is Susanne Mecklenburg. I work for the European Space Agency and I'm the head of their climate office. I work in EXAT in the UK at the Harwell campus. The UK is the lead partner, or the driver, I should actually rather say, of the Truth mission, which is done in collaboration with the European Space Agency, of course, and other partners in the consortium from other European countries. It's a very important collaboration. I think Truth will bring a lot of new knowledge for something very important for climate data, which is accuracy, precision, uncertainty characterization, and we're very much looking forward to having these data. The Paris Agreement sets out different areas that we would like to pursue. Two of them are mitigation and adaptation. It's quite important because we are seeing now in 2023 that our mitigation efforts are not as successful as we thought they would be. So each and every state has declared what they want to do in order to reach net zero in 2050. But if you sum all these pledges across the world up, we can actually see that we were nowhere near of limiting global warming to 2 degrees or 1.5 degrees even. So I think the adaptation is actually getting more and more important. What satellite data can do for this question is that they are delivering climate actionable information. So they tell us where we stand, and they also tell us, in combination with climate models, where we are going to go in the future. And that's really important, to have these forecasts that go into the future to tell us where we will be in, let's say, a decade or two time. And when we know that, we can actually put measurements in place to adapt to this changing climate. ESA is an international organization that combines European states. So there are differences in the approach of working, of your ways of working with different colleagues. You need to be open to maybe also covering tasks that are not necessarily in your very narrow specialization that you bring from, let's say, a PhD or a postdoc, or from your experience in industry. I have many colleagues that have taken over also projects that are not in their original scientific specialization, but I think with a good background, technical and scientific background, I think you can sort of branch out, and actually that makes your life even more interesting, I think.
My name is Simon Pinnock. I'm an Earth observation applications engineer at the European Space Agency's Climate Office in Harwell in the UK. I work on a program called the Climate Change Initiative, which is a European Space Agency program which is designed to provide satellite-based data sets of the essential climate variables that are needed for monitoring and understanding climate change. So there's a lot of new satellites being launched at the moment, and a lot of those potentially can be used for monitoring climate. But one of the problems is that because a lot of these are smaller, faster, cheaper missions, so quite small satellites, they can't afford to put the very, very complex, expensive calibration systems on board that allow them to be directly used for climate research or for building climate time series. So a mission like Truth's will allow us to do this intercalibration to actually improve the calibration of these smaller missions and then extract a lot more value than we could from them otherwise. And because there'll be a lot more of these missions in future, we'll have these huge constellations that now we can calibrate with Truths and that we can now use for climate that we couldn't have otherwise used. It'll narrow down the uncertainties on the different data sets, and also mean that so these data sets will be more accurate, and the level of uncertainty in them will be better characterized. And then, of course, that level of uncertainty is really important when it comes to using those data sets and using that information to make decisions about how to tackle climate change. Without a good understanding of the uncertainty, your decisions are also very inaccurate. So that's where Truths will come in and be a great benefit. I think one of the skills that's very important is being prepared to work outside your comfort zone, and being prepared to sort of push the boundaries and not being afraid to go and learn new topics and, let's say, learn new satellites that are coming along and new observing techniques, and then put them to use. And the more you do that, the more you get a broader understanding of everything that's available. And you can also take techniques from one field and put them to work in other fields where maybe they haven't really sort of been used traditionally. So I think having a sort of cross-disciplinary approach is very useful, and particularly having the courage to do that because particularly when you've finished a PhD, sometimes you're in a very, very narrow scientific field. But if you can break out of that a bit and be a bit broader, then you'll find you're able to solve more problems, and it's also more interesting, because the more you go along, the more interesting things you do, the more opportunities appear.